Okay, so here we go. We've been doing a lot of geology stuff. We've been talking about volcanism and earthquakes and lava and magma. But one thing we haven't done is we haven't talked about some real basic principles of geology. So what I want to do today with you is I just want to talk about some of the basic ideas that we have that help us figure out what's going on with the Earth. So we're going to talk about five major principles, and then I'll have you guys do some practice stuff, and then we can talk about them later or next class period. But the five big things that I want to talk about today are uniformitarianism, superposition, original horizontality, the law of cross-cutting relationships, and the law of included fragments. Now, those sound pretty fancy, but there's not really a lot to those. They actually are pretty simple. Applying them can get a little tricky, but the basic ideas aren't too tough. So let's walk through each of these things. Uniformitarianism, just like it says, basically says the geologic processes that we have today are the same types of geologic processes that were forming the Earth years ago. Once upon a time, we thought that things were formed, and then that's just sort of the way that they were. But we realized that rivers flowing today carve streams, and millions of years ago, rivers were flowing and carving streams. Today, volcanoes are erupting. Years ago, volcanoes were erupting. So we assume that the same processes that we have now have always been around to shape the Earth. Now, there are some big things that we don't see happening. Um, there are big cataclysmic events like the big meteors that took out the dinosaurs. But just because we don't have something today doesn't mean it wasn't there in the past. This is our way of recognizing that these procedures help with figuring out things the way they were. All right. The next one is pretty simple. The law of superposition says that rocks at the bottom of a sequence are older than the rocks above. So if you see a layer of rocks, the one at the bottom formed first, and then there was a layer on top of it, and then a layer on top of that, and then a layer on top of that, and so on and so forth, so that the oldest rocks are the at the bottom, and the youngest rocks are formed at the top. Pretty simple, right? Moving on. The law of original horizontality says that sedimentary rocks are laid down in horizontal layers. They don't form at angles, they form flat. So if you find a bed of sedimentary rocks that are tilted, what's happened is those beds were laid down flat or horizontally, and then some other force acted to tilt them or fold them or bend them, but they were originally laid down flat. All right, so that's kind of some basic stuff. Now we start to get to a couple others that help us figure out more complex situations. The law of cross-cutting relationships says that when one body of rock cuts across another or intrudes into it, that the cross-cutting body of rock is younger than the ones that it cuts across. So if you look at the diagram here, these numbers show the order these things happened. So this red layer, number 1, was laid down. Then the green layer, number 2, was laid down. And then the purple layer, number 3, was laid down. And then number 4, either because there was a crack or a fault that formed here or magma was pushed up into this crack, number 4 intruded through those. So that's the next youngest layer. And then it eroded on the top here. And then layer 5 was put down on top of that. So 1, then 2, then 3, then 4 intrudes into it. We get erosion. And then layer 5 happened on top of it. And this one is pretty similar. It says that the law of included fragments says that when a rock body has pieces of another rock body in it, then the pieces have to be older than the rock in which they're part of, because you can't, these things didn't come into existence inside the rock. So they existed and then they were trapped or laid down inside this. Now that's a little bit different because this has to be younger than the pieces that were in, and these pieces have to be older than the pieces that were in there. They can't, the rock can't have formed and then something produced out of nothing. So these fragments, for example, may have worn off of the sample on rock A, broken off, and then they got included in rock B. So let's look at some examples. We have our relationships all laid out here again. It's the principle of superposition. And here you can see, a big bed of sand near an ocean is going to be laid down in a big flat layer, and then it's just going to build on top of it. And we can see this in road cuts around when we drive, especially northern Wisconsin, southwest Wisconsin. There are some big road cuts. You can see that these things are all laid down horizontally. But if you have something like this, these are all tilted. And so at one point they were formed flat. And I see this body of water here. There's a good guess that maybe water eroded underneath it and wore it out. And then the material that was supporting this disappeared. And these things then tipped and fell down into the ocean. Other forces that could happen would be tectonic plates pulling apart or colliding or having things erupt up through the ground underneath them. But you could be sure that when these were formed, they were originally flat and horizontal. Okay, so lateral continuity, I think the easiest way to show this is to show you some pictures of the Badlands here in South Dakota. When you look at this, you can see this big, thick pink layer, and then some white, and then some brown, and then some white, and then a very distinct pink layer right here. And if you look around the Badlands, other parts of it, now these aren't connected, obviously, but you can see the pink layer and the white layer, and here's that distinct pink layer again. The assumption here is that this was all laid down in one big body, and then erosion has taken out these pieces within here. But this pink layer corresponds to this pink layer. And we can say, well, we could actually follow this one around. But the assumption it was all happened at once, and then erosion took out parts of it, or a fault may have pushed a piece of it out of there. Okay, so intrusive rock, like igneous rock, magma forming underground. So you get this big sort of brown area here. It could be dirt or rock, but you see this magma chamber, it's always under pressure. When it gets a crack or an opening, that pressure will push it in, and you can form these sills and dikes. They call them xenoliths. But all of this magma that gets pushed in here is younger than this brown that it was in. So because it's intrusive, it's younger than what it was pushed into, which has to be the older stuff. Okay, and so here we see you've got some, it looks a little brown, I guess. It doesn't look so much pink, but you have this pink granite here and this igneous black magma pushed up in there with a different type of material, maybe basalt. And then you get these layers now. So the pink is the older, and cracks formed and that magma pushed up in there. And now you get this pattern of the black dikes formed inside that pink granite. Okay, so here's a couple of examples. These are kind of complicated, so I'll look at this one and we'll just walk through it. So what I want you to do for next class period is I want you to predict here what order these things happened. So B is this green layer. We're going to say that A refers to this brown layer. D is this black thing that's pushing through there. C is the red body of rock here. And E, these two parallel orangey red lines, are going to represent this break or this fault that pushed this piece of land up. So thinking through those principles that we talked about, tell me what order they happened in. So again, B is the green, A is the brown, D is the black intrusive body here, C is this red intrusive body, and E is the fault. And I want you to tell me what order those things happened in. Make a prediction and be ready to share that with us next class. And then I'll have some other things for you guys to do.